So we talked a bit about continental drift in the last video. The modern version of continental drift is called plate tectonics, and in my hands I have a typical map showing where the plate boundaries are. You can have a copy of this somewhere in your textbook. Now, the idea is that the entire outer surface of the Earth, the hard outer shell that we call the lithosphere, is fractured into about a dozen to 15 different pieces, depending upon how you count the little bits. And these pieces are called plates. And these plates move on a little bit of a squishier layer underneath called the asthenosphere. I like to use the analogy of a pool. Let's imagine that you are the only one in your neighborhood with an in-ground pool. And it's July and it's hot and you are incredibly popular and everybody comes over to your house with their inflatable little rafty thing that they're just going to lay on and enjoy the pool. Well, pretty soon you've got 15 people laying in the pool, and the surface of the pool is pretty much covered by these rafts. Now, let's say that you happen to find yourself stuck in the middle of the pool with all of these rafts surrounding you, and you want to get to the edge of the pool and get some iced tea. Well, you've got to make your way among these other rafts that are bumping up against you. And there's 3 different things that could happen. It might just happen that you are fortunate enough to be in a place where there's a little bit of room and you can actually move apart from the raft next to you. And if you do that, you can see the squishy stuff, water in this case, that's beneath the rafts. It may happen, however, that you're right up next to somebody, but you can very politely just sort of squeeze by and it's going to make a really annoying sound on plastic on plastic. But in some cases, you have to be a little bit rude. And you're going to have to collide with another raft to get to where you need to go. Now, what can happen is that if you're incredibly aggressive, you can actually go up and over somebody else's raft and push them down into the water. Or if you're both equally aggressive, you will push up into each other and you will both come out of the water and everybody will laugh at you. I've really just explained the 3 different kinds of plate boundaries. The place where 2 plates move apart is a divergent plate boundary. Now, the soft and squishy stuff underneath the 2 plates is not water. It's actually molten rock. And so if you pull 2 plates apart, new molten rock comes up and creates new plate material. One place this is happening is in the middle of the Atlantic Ocean, the so-called mid-Atlantic ridge. So the Atlantic Ocean is actually getting wider as new material is coming up and adding to the sea floor of the Atlantic Ocean. So the Atlantic Ocean is growing from the middle, adding new material, and so Europe and America are getting further apart. Shh, don't tell the airlines, they'll raise the prices. Another kind of plate boundary is what we find in Southern California. This is where 2 plates rub against each other. Now, rubber rafts rubbing against each other, it can be a bit annoying, but at least they're kind of slippery and they'll go by. But imagine rock trying to slip by another conglomeration of rock. It's going to be, okay? It's not going to be a nice smooth transition. So obviously we're going to get earthquakes into this. But that's a transform or a transform fault boundary. Plate material is neither created nor destroyed here. The third kind, remember the first kind in divergent, we created new plate material. In the transform, no creation, no destruction of plate material. In the third type, we're going to have the destruction of plate material. Either one plate is going to go up and over another and push that other plate down where it's going to melt, recycling it, later making new plate material somewhere else. Or if both of the plates come together and push up, we create mountains. This is what happened when India slammed into Asia, creating the Himalayan mountains millions of years ago. Now, how do we know whether a plate is going to go above another one or if they're going to go up together? Depends on the material. If one of them is ocean and the other is continent, or they're both ocean, there's a difference in density, and the denser plate will sink down or subduct. But if it's 2 pieces of continent, neither one will get out of the way. They're both the same density, essentially. So they'll both get pushed up.